Have you ever looked at a picture of the Great Pyramid of Giza and just wondered, how did an ancient civilization, without the help of modern machinery, build something so colossal, so precise, that it has stood for over 4,500 years? Today, we re-peeling back the layers of sand in time to uncover the incredible story of this engineering marvel. Let's start with the basics. The Great Pyramid was built for the pharaoh Khufu, and it's the largest of the 3 pyramids at Giza. We're talking about a structure that held the record for the tallest man-made building in the world for nearly 4,000 years. It's made of an estimated 2.3 million stone blocks, some weighing as much as 80 tons. To put that into perspective, an average car weighs about 2 tons. So, how on earth did they move these massive blocks? Forget the myths about aliens or lost super technologies. The real story is far more impressive because it's a story of human ingenuity and incredible organization. For a long time, the common belief, popularized by Hollywood, was that the pyramids were built by a massive slave labor force, but modern archaeology tells a different story. Excavations of a nearby village and tombs have revealed that the builders were skilled, well-fed Egyptian workers. These weren't slaves, they were respected members of society. They received good food, including meat and bread, and proper medical care. We've found evidence of healed bones, showing that injured workers were treated and cared for. They worked in rotating shifts, organized into teams with names like the Friends of Khufu or the Drunkards of Menkaure. This was a national project, a source of pride, built by a dedicated and organized workforce of around 20 to 30,000 people at its peak. So, how long did this monumental task take? It is estimated that the Great Pyramid was constructed over a period of about 27 years during Khufu's reign. That means they had to quarry, transport, and place one massive block every few minutes, 24 hours a day, for nearly 3 decades. The sheer logistics are mind-boggling. The stone primarily came from 2 places. The bulk of the pyramid, the inner core, was made of limestone quarried right there on the Giza Plateau, but the outer casing, which would have made the pyramid gleam a brilliant white in the sun, was made of fine, white Tora limestone from across the Nile. The heaviest granite blocks, used for the king's chamber, were quarried in Aswan, over 500 miles to the south. Transporting these stones was a masterclass in logistics. For the Aswan granite, they likely used massive barges to float the stones down the Nile River during the annual flood season. Once at Giza, they would have been moved from the river to the construction site. Recent discoveries suggest they might have built a system of canals and a port right at the base of the plateau, making this process much more efficient. Getting the blocks up the pyramid is where the real debate among experts begins. The most widely accepted theory involves the use of ramps. But what kind of ramp? A single, long, straight ramp would have been impracticably massive, eventually becoming larger than the pyramid itself. So, other theories have emerged. One popular idea is a spiral ramp that corkscrewed around the outside of the pyramid as it grew. This would allow for a more manageable gradient. Another compelling theory suggests an internal ramp system. This ramp would have spiraled upwards within the pyramid's core, a kind of internal highway for stone blocks. This would explain why we don't see any remnants of a massive external ramp today. In fact, some thermal scans of the pyramid have shown anomalies that could point to such an internal structure. Regardless of the exact ramp configuration, the Egyptians had incredible tools at their disposal, just not the ones you might think. They used copper chisels and saws, which they would have had to constantly resharpen, to cut the softer limestone. For the harder granite, they used a brilliant technique involving pounding the stone with dolerite balls, a type of very hard rock. They also likely used wet sand as an abrasive with their copper saws to cut through the tough granite. To move the blocks on land, they would have placed them on wooden sledges. A famous tomb painting shows a scene where workers are pouring water on the sand in front of a sledge. This simple act reduces the friction dramatically, making it much easier to pull the heavy load. It's a perfect example of using simple physics to achieve incredible results. Once the blocks were at the right height, they had to be placed with breathtaking precision. The base of the Great Pyramid is almost a perfect square, with the sides aligned to the 4 cardinal directions with an accuracy that is astonishing even by today's standards. The sides are off by just a few centimeters. How did they achieve this without GPS or lasers? They likely used astronomical observations. By tracking the rising and setting of a star, they could create a true east-west line. From there, they could use simple geometry with ropes and stakes to lay out a perfect right angle and extend the lines to form the square base. They also had to level this massive base area. They probably did this by creating a grid of water-filled trenches. By marking the water level and then draining the trenches, they had a perfectly level reference point across the entire site. As you go inside the pyramid, the precision is just as impressive. The passages are perfectly straight, and the king's chamber is a masterpiece of stonework. The granite blocks are fitted so tightly that you can't even slide a piece of paper between them. This wasn't just about stacking blocks. It was about creating a stable, enduring structure designed to last for eternity. The internal structure itself is a marvel. It features 3 main chambers: the unfinished subterranean chamber, the so-called Queen's Chamber, and finally, the King's Chamber at the heart of the pyramid. Above the King's Chamber are 5 stress-relieving chambers, a brilliant engineering feature designed to distribute the immense weight of the pyramid above and prevent the King's Chamber from collapsing. This shows a deep understanding of structural mechanics. So let's recap this incredible feat: a skilled, well-cared-for workforce of tens of thousands, a construction timeline of less than 30 years, ingenious methods for quarrying and transporting millions of tons of stone, a sophisticated system of ramps, whether internal or external, and a level of precision in layout and construction that continues to baffle engineers today. The Great Pyramid of Giza isn't a mystery born of alien intervention. It's a testament to the power of human collaboration, ingenuity, and unwavering dedication. It shows us what people can achieve when they work together towards a common, monumental goal. It's a story of real people using their minds, their strength, and their skills to build a timeless wonder. Next time you see the Great Pyramid, don't just see a pile of stones. See the organized society, the brilliant engineers, and the thousands of dedicated workers who poured their lives into creating something truly eternal. It's one of history's greatest stories, written in stone. Thanks so much for joining me on this journey back in time. If you enjoyed this deep dive, make sure to hit that like button and subscribe for more explorations into the wonders of the ancient world. Let me know in the comments what ancient marvel you'd like us to explore next. See you in the next video.